Welcome everyone. Today we are going to be going over local AI, when it's useful, when it's not. I'm going to go over some specific models, critical points of failure, some security issues you have to keep in mind. This is going to be part one of part two. The last video that I uploaded on YouTube was 3.5 hours long. It's probably a little too long to be posting on YouTube. So I'm going to be breaking these videos down into shorter, more usable chunks. Part two is going to get pretty technical. We're going to be going over firewall rules. For example, if you want to run agents and harnesses inside of a virtual machine, which is one of the things I'm going to discuss in this video, that way you will know how to properly configure your firewall and your bare metal operating system in order to be able to run models at full speed on your GPU, but then have that pass through to the virtual machine. So this video, we're going to get into a lot of these details that are important if you are going to run a local AI on your computer. I do like local AI, but it does have some downsides that go beyond just the capability aspect. For example, unless you have a really good computer, you're not going to be able to do as much. They don't score as high. So that's what we're going to get into. So the first thing, this is the most important aspect when it comes to using local AI, in my opinion, is as far as privacy goes, assume anything you do on a device you don't own will be forever logged. And this even goes for these AI providers that say they are providing a private cloud service where you can pay for API usage. Let's say you go to one of these websites, you pay with Monero, they do exist, and you can use one of these cheap models and run a bunch of queries through there. And they will say, for example, OpenRouter will say something to the extent of, as far as we know, this provider does not collect any of the prompts that you run through it. They don't train on the data. The thing is, I don't think that can be relied on. It's safer to assume that anything you do on somebody else's computer will be forever logged, especially with something like an LLM. These things are made to farm as much data as possible. So it only benefits them to train on it. And it might be a little bit of a leap to say that even on something like an enterprise plan for something like Anthropic, that they're training on people's usage. But that is something that's safe to assume. And that's one of the things that I would say is the biggest benefit of running it on your own hardware. It certainly isn't speed. It certainly isn't capability. Even though there are good local models that are out there, privacy is by far the biggest benefit that you get if you're going to run it locally. Cost is also another factor. I would say depending on what it is that you're doing, it's not as big of an issue as it used to be. Because if you are running this on, let's say, a RTX 5080, and you are jumping up to, let's say, 80 to 100% usage on your GPU, well, is it really any cheaper when it comes to the power usage if you're running a local Quen model versus just running DeepSeek Flash or a lighter weight model like Gemma 4 off of a place like OpenRouter? At the end of the day, it's really not going to be significantly cheaper because not only do you have the power issue, you also have the issue of heat is what tends to kill a lot of electronics. The more stress you put on your hardware, the sooner it's going to wear out. And of course, if you have good hardware and you didn't lose the silicon lottery, you should have equipment that lasts for years, but that is something to take into consideration. The other benefit that you might have with local AI over running something on cloud is you're not going to be rate limited. By the way, I just also want to throw this out there. I don't assume people's technical knowledge when I make these videos, just like the last video where I went over an introduction to privacy and cybersecurity for home users. Is you do have to have some technical capability, but I don't want to assume that everyone already knows this. That's why I'm going to go over this. The next aspect is you can keep it fully offline. The problem with fully offline is if you don't have tools that it can use, even on frontier models, by tool usage, that would be things like being able to do web search, which will greatly help the queries that you get back from the LLM. But you can run it air gapped. So there's certain places, like if you are in a healthcare setting or let's say you are working on super sensitive IP and you can run a good model and keep it off of the internet. Well, that may be something that would be a benefit to you. Or if you just don't want people to be able to spy on it, that is a benefit of it. The other thing is the freedom of model choice, and you can download models from multiple places. One of the favorite places that I go to get models, local models when I need them, is this website called Hugging Face. And you can come in here and search and find just about anything that you could possibly want for a model to be able to run on your computer. So like the latest Quinn 3.827B model is out. We're actually going to get into that one. As of the time of me recording this video, this just released today, and it looks like it is a really solid, high quality model. But anyway, Hugging Face is one of the options. It's one of my favorites, where you can go to find just about any model that you want. The other thing is local is actually a lot better now. And even though you're not going to get frontier results, what I would say is we're probably entering a world now where it is good enough. So for example, how when you're building a computer, you can build with either a dedicated GPU or you can do it with something called an APU. The GPU gets built into the CPU, and it's not as good as a dedicated graphics card, but it's good enough. If you're running a 1080p and you're not trying to get ultra graphics on everything, it's good enough. And I'll give you an example. Quinn right now really is the best tiny little open source model that you can find. Quinn 3.627B. By the way, this is livebench.ai. Another good one is artificialanalysis.ai. Both of these have AI benchmarks. This is just the one I prefer to go to. It's a little cleaner and faster to navigate, but they also don't test as many models. Now, I did mention Quinn 3.827B just earlier today released. It has not been put up on the benchmark for either LiveBench or Artificial Analysis as of the time of me recording this video. But from the benchmarks that I have seen, it looks like it is roughly going to be equivalent to Claude 4.6 Opus. If that's true, if it really is that good, that would be a significant leap for it. I would say it's roughly going to come in somewhere in this range right here. This is now a model that you can use to do just about anything you would ever want to on a local computer. You could set it up inside of a good agent harness, give it tasks, it can go out and do it. If I was going to be writing code with it, I would still say it would be better to go with one of the frontier models, whether it's LunaMax, because you can get so much usage with even a $20 plan on OpenAI, or you could go with Claude, you could go with Kimi, you could go with Grok. Grok is actually pretty solid now. 4.5 is pretty good. 4.6 should be rolling out. Where I'm going with this is local is really solid now. And the other nice thing is Thinking Machines just released a model called Inkling. And let me pull this back up here. If I go back here, Inkling, extra high effort, and then they've got a smaller model that they're working on. Inkling is a open weights model, or they are at least trying to work on open weights, which is good. So we've got plenty of options that are out there. I would say right now, Quinn 3.827B, if you have the hardware for it, is going to be your best option. We'll get into quantizations here pretty soon. Let's say you don't have a 5090 that you could run. You might be able to get it down to like a Q2 quantization and be able to run a lot better. Now, this is something that is a downfall of local AI. Critical point here. You are the system administrator. You can completely destroy your system with this stuff. I'm going to cover security in this video specifically because there are security downfalls with this. We're also going to get into that on the part 2 video, where I get into things such as firewall configuration. This is something that has caused a lot of problems for people, and it was especially like when OpenClaw first released, is people had things like exposed WebSockets. So people could go and see everything that they were doing with their OpenClaw agents. They had all of their personal info on their agents that was running it. Some people were giving it credit card access. One guy had, I think it was about a $3,000 charge on his credit card to go buy something, and he didn't intend for that to happen. But if you don't configure these properly, if you don't give them the proper guardrails, you're going to break stuff on your computer. You could get some pretty nasty malware. Again, I'm going to get into that here pretty soon. But that is something to keep in mind, and I will get into some of the nuances of that both in this video and when we start configuring things for part 2. Let's go over the hardware requirements real quick. Apple works a little differently. The vast majority for the time being of the world is still using Windows. More people are starting to use Apple and Linux, partly because Windows is having some major problems coming up over the past couple of years. But if you have not used Apple, there's been a lot of buzz, especially on Tech Bro Twitter, of people buying Apple hardware just to run local models. It does work really well, and that's because it unifies the RAM. So, for example, and what I mean by that is both the RAM that you would think of on a Windows computer and the VRAM, it's combined. So if you buy a Mac Mini, let's say, or let's just say a Mac Studio with 128 gigabytes of RAM, you can run some super capable models, and you're going to spend less on that than you're going to spend on getting multiple 5090s to be able to reach that same level of VRAM. It's not quite as fast as running it on something like a 5090, but it is still really good. They're making a lot of money right now because of the way their system's built. It just works well. The next point is GPU is really the only good way that you can run this. I'm telling you guys, I've ran this on CPUs before. I've tried it. At best, you're going to get a couple of tokens per second. Maybe unless you have one of the, let's say the AMD 9800X3D that has the extra cache on the CPU. I haven't tried those yet. But if you just try running this on a regular CPU, it's going to be way too slow. GPU is really the only good way that you can do it. So what's going to happen here is if you try to run a model, let's say that to run properly would need 32 gigabytes of VRAM, but you have a card with 8 gigabytes of VRAM, and so it has to use regular RAM to make up for that, it's going to slow it down quite a bit, in my opinion. I think there's a certain point where it becomes so slow that it's not even worth using, especially if you're going to use agents, if you're going to use loops, where it might be running you give it a loop and you say, I need you to do this thing, and it's going to run for, let's say, 2 or 3 hours. If it would take, like, let's say 2 to 3 hours and it was running at a proper speed and you don't have the resources for it, it's going to take days. It's, in my opinion, it's not worth it. So that is something to keep in mind. Now, quantization, when you're looking at quantization, so for example, if you're going to run a 70B model, you would need about roughly 140 gigabytes of VRAM for FP16. These are numbers, and I'll show you some models here on Hugging Face for FP16, and roughly about 40 gigabytes for 4-bit. And then 1 and 2-bit quantizations, you can use those. You're going to have a lot of drop in quality. So let's say you are going to go to Hugging Face and you type in Quinn. Let's go to Quinn 3.6. So if you look here on this uncensored model, I'm going to come back to the uncensored model when we cover security. People might think this is a good thing to use. It has its pros and cons. But if you look at this, you'll see 2-bit, 3-bit, 4-bit. Now, this is a 35B model, so you might be able to run this okay on 4-bit for most people. If it doesn't work, you can run it on 2-bit. I will say generally about 4-bit is where it's fine. You might have a few percentage points in difference in performance, the quality of your outputs. When you go down to 1 or 2-bit quantization, it still is having quite a bit of an effect on the quality of your output. So roughly, let's say you have 8 gigabytes of VRAM. If you want to run something at a good speed, an 8 billion parameter model at Q4 quantization is probably about as high as you're going to be able to go. 24 gigabytes, roughly 32B model at Q4 quantization. So for example, I'm running on a NVIDIA 4070. I can use the Gemma 4 E4B model, and it runs pretty good on my computer. I can run 27B models, but it's much slower. For me, it's basically unusable, but that's something that maybe you'd be okay with. That is something to consider, though. The next thing I'm going to say is with how out of control prices are right now, I saw this come up the other day because people are getting super upset with the price of hardware. The RAM manufacturers have completely screwed up pricing. It's like they completely left the consumers behind. The people who actually built these companies, helped build these companies, and these companies have turned their back on the customers. All of these people who spent years buying these graphics cards and all of this RAM. These companies are now saying, well, we're going to sell the data centers and you're either going to pay the price or you don't get hardware. So I saw this was about a week ago that 5090s are roughly about $3,000 right now, $4,000. It's a lot of money. It's ridiculous and it should not cost that much. If you didn't get in earlier to get your computer upgraded, you might be locked out for a while. If you don't have good hardware in order to be able to run local models, you might be stuck running cloud models for a while. And eventually, at some point, I'll make a video covering if you want the more privacy-focused LLMs. And let's say you don't want to get a subscription to something like OpenAI or Anthropic, I'll cover that. There are ways that you can pay with Monero, or you could pay through OpenRouter, and supposedly you're getting a somewhat private experience. Again, goes back to what I said at the start of the video. Don't assume. I don't think it's a good idea to assume that your outputs and your inputs are not going to be permanently captured, but that is something to consider. And the fact is that most computers are going to be too slow for a solid local model. Now, hopefully, Qwen 3.8 27B will get down to, let's say, Q1 and Q2 quantizations, so we can have something that's actually pretty good. Yeah, it's going to be a sharp drop-off, but even at Q1 or Q2, they might end up performing better than Qwen 3.6 27B. If that's the case, that'd be pretty solid, and there should be plenty of computers that could run those models. But we'll have to see how that works out. Okay, let's get into the security aspect. This is going to be one of the most critical parts, and when I get into the part 2 video, I'm going to cover security extensively. Like I said, you are the system administrator if you are going to run local models. If you don't set this stuff up properly, you can completely destroy your computer. A couple of years ago, I made a couple of videos. I do think these would be worth watching if you don't have a good idea of how bad some of this malware can be. This first one was called Logo Fail. Now, by the way, Logo Fail, Black Lotus, don't worry about these too much. These have been patched as long as you have a motherboard that was made even within the past like 5, maybe 7 or 8 years. Then you should have had a firmware update that fixed this vulnerability. This was across a lot of different motherboard manufacturers. The Black Lotus, so that was called Logo Fail. And then the Black Lotus malware was an attack on Secure Boot. So what happened there is if you got that malware on your computer, it would sit in your boot drive. So for example, Windows has a boot drive. This also affected Linux, if I remember correctly. It's been long enough since I made the video. I don't remember for sure, but I'm pretty sure Linux also got affected by this, where it launched when the computer was booting so it could hide from antivirus and your computer couldn't detect it. That got patched. Secure Boot got patched. Logo Fail was patched. But the problem is so for example, this is not going to be the only time we ever see this malware pop up. These were just 2 variants. There's numerous variants out there. Fortunately, BIOS malware is super rare. It's not something that comes along often. Logo Fail is an example of it. But let's just use an example here. Logo Fail, if you got this, what happened was it would live where your motherboard's logo would show up when you would boot your computer. And so, for example, if you wiped your hard drive, let's say you found out you did have malware and you say, well, I'm going to wipe it, it wouldn't work because it's living in your BIOS. So you had to flash your BIOS. If you would have got this on your computer, you would have had to have flashed your BIOS in order to get that cleaned off there. It's a little bit of a process. Anyway, this stuff's been patched, but let's say you want to run agents. Let me pull up this uncensored model here. Let's say you want to run an uncensored model with OpenClaw. And especially with some of these uncensored models, or even just a regular model that doesn't have as good of guardrails, one of the things that's been happening a lot recently is an attack called prompt injections. And this has been an issue even with malicious websites where you will give an agent a task and it will go search across, let's say, 100, 200 websites to try to find the info that it needs to complete the task. And it goes to a website where people could go click on the website normally and they wouldn't see anything. But some of these bad actors are doing things like building in malicious instructions into the HTML so that when an AI agent goes and reads it, that the intention is that it's going to cause a prompt injection attack. That's just one of the problems you could run into. The other thing is maybe it downloads a file that's actually malware. This is why these frontier models that have guardrails built in, they are a double-edged sword, because I'm seeing some ridiculous refusals, especially with Anthropic's Fable model, where people are paying for what they think is Fable, but then it gives a refusal because it thinks that what it's doing might be malicious. And in a lot of cases, it's not, so it downgrades it to Opus, which to me is ridiculous that people are having to pay for that, but that's a topic for another time. But that gets built into there because Anthropic, OpenAI, xAI, these companies want to minimize the chance of something going malicious, going wrong. It makes them look bad. Whereas you could run one of these uncensored models on your local computer and you can see this, for example, 0 out of 465 refusals. So on your main model, it looks like these guys don't list. One of the models actually does say how many refusals the regular model had versus this. Let's say the regular model, you might get 450 out of 465 refusals. This is completely uncensored. So that can be a good thing and a bad thing depending on what it is that you're trying to do. If you're trying to do software development, or if you're just giving it full computer use access, it might not be the best idea to be running one of these uncensored models on a bare metal OS, meaning your host operating system. If you're not familiar with that, we'll get into that here in just a moment. It's not going to be as bad of a problem on a virtual machine as long as you have properly configured it. But let's just take this scenario. A new piece of malware comes out that attacks, it doesn't even have to be the BIOS. It could just be some new Windows malware. You're running an agent on your host operating system, and you give it a task, and it doesn't refuse to do something. It goes and it gets a prompt injection attack, and it takes, so you have a piece of malware take over your computer. That's where this stuff is a problem. That's why I'm saying, if you're going to run these models, you are the system administrator, and if you don't configure these properly, you're going to break a lot of stuff. So let's cover bare metal versus virtual machines versus containers. So this is a critical point of failure. Most people don't really look at this. What I'm seeing right now is that the AI bros, the people that are really getting into running LLMs, do seem to pretty well grasp this. But like, for example, earlier in the video when I was talking about how people, when OpenClaw first released, how they were running it, and they had things like exposed WebSockets, or in this case here, we scanned 18,000 exposed OpenClaw instances and found about 15% of community skills contain malicious instructions. What happens here is people who roll this stuff out, most of them don't understand how cybersecurity works. They don't understand what virtual machines are. They don't understand that it's important to properly vet skills before installing them on your computer and having agents run them. So proper configuration here is critical. So your risk tolerance is a significant factor in how you're going to use any AI. And it doesn't matter whether it's cloud or local. Your harnesses, having strict measures built in through Codex and Claude Desktop, even on a bare metal operating system. So let me say what bare metal operating system or the host operating system is. If you're running on Windows right now, you boot up your computer, you're using Windows, that is what's called the bare metal operating system or the host operating system. That is what's running on your hardware. A virtual machine, if you have never used it, is basically what it sounds like. You can use there's different software out there that can do this. There's QEMU. If you're using Windows, as long as you're using Pro or above, there's something called Hyper-V, and a virtual machine lets you set up a virtual computer. It will use your computer's resources, but it's segmented away from your host. As long as you're using what's called a Type 1 hypervisor. There's Type 1 and Type 2. Type 2 would be an example of something like VirtualBox, where a Type 2 hypervisor shares the host's kernel. If you're going to be running local LLMs, or you're going to be running harnesses, having loops running, especially if you're going to use uncensored models where they're not going to refuse to do something that might be malicious, definitely make sure you're running on a Type 1 hypervisor. If you're on something like Hyper-V, for example, then you're good to go. Anyway, a virtual machine is segmented away from your main computer. So on a Type 1 hypervisor, it gets its own kernel. You start it up, and it is its own computer. You can use it like if you were to boot up Windows and you installed a Hyper-V virtual machine, you had a Windows virtual machine, you can boot it up, bring it up just like a regular application window, and that is its own separate operating system. Now, I will tell you, when I use Codex, Claude Desktop, Grok Build, the Hermes agent, it doesn't matter any of that stuff that I'm using, it gets ran on its own virtual machine that I have properly configured for security. I harden the security settings. I make sure the firewall is configured properly. I do not just let this stuff run on bare metal. Your risk tolerance might be such that you are okay with doing that. If you are going to do that, I recommend that, my personal recommendation is, if you're going to do it, only use Codex or Claude Desktop at this time, because the OpenAI and Anthropic models have the best guardrails built in, where it's less likely that something's going to get completely destroyed. It's going to do something that it's not supposed to, that you never intended that it would do, but it got malicious instructions and it followed through with them. That is something to be careful of. And also, like I've been talking about in this video, is the privacy aspect. It's better to just keep these harnesses and these models running on their own computer where it's away from your main data. The next aspect is bare metal is going to be important for running the model itself if you only have one GPU. So I said that there's going to be some nuance to this right here, as you can see on the screen. Bare metal, what I do on my computer, you may choose to do something else. There's a couple different ways that you can tackle this problem. What I am choosing to do right now, and it seems to work okay, is I have written a firewall rule through Windows Firewall that allows my Hyper-V virtual machines to be able to connect to my host operating system. And I run something called Ollama, my computer, on my host operating system. That way, Ollama has access to run the model, and it can run it on my GPU. And let me just pull this up here real quick. We're going to get into this in part 2 when I get to that video. This is Ollama here, where you can download this software, runs on your computer. You can select what models you want to run through it. It actually works pretty well. But that's how I choose to do it. That way I can still run a local model on a GPU, and it can run at full speed, but that way I'm still keeping everything on the virtual machine. Like I said, the firewall configuration is important because there are ways to set up bad rules that could cause issues for you. You can choose to use containers. They're not generally optimal. What I would say is this: if you're going to be doing just basic Google searches, if that's all you want to use your local AI for, you could just use something like Ollama on your host OS. And there's an option on Ollama in order to be able to log in to the application, and it can do web search, or you could do something, you could use a container service, either Docker or Podman. I found that Docker is generally easier to work with. Podman works as well, though. They're both good for different reasons. But what you can do is run in something called a container. So Docker is a container where it gets its own system. It gets its own what's called a headless browser. So for example, if you set up the Hermes agent inside of a Docker container, you allow Docker to be able to use Ollama for your local LLM, then it can run inside of its container, have a headless browser so it can do web searches, do whatever it needs to do. And let's say you want to have it, you give it a loop or a goal, and you want to have it save, let's say, a markdown file. It will save inside of your Docker container. Then you can bring that file and bring it over to your desktop when it's done, if that's something you want to do. I don't find that ideal. There's a couple different problems with containers. First of all, the security problem. Like a Type 2 hypervisor, they do share the kernel with the host operating system. There is a lot of risk for things to get screwed up. They are still better than running on a bare metal operating system. But if you're going to be running loops, you want to have agents doing stuff in the background, and you want to keep it private, virtual machines is still going to be the best option that is out there for the time being, because then it has an entire computer to use. It's easier for you to work with. It's easier for the agents to work with. You can have multiple harnesses running on there. That's why I like to give them their own machine to be able to work with. But if you're just going to do basic Googling type work, then Docker can work, or you could just run Ollama on your host OS. But like I said earlier, Type 1 hypervisors are the best choice because you get the most isolation, and agents will have their system, their own system to be able to work on. So coming up in part 2, we're going to go over container and virtual machine setup, the proper security settings configuration if you're going to use one of these. This stuff is critical. Like I said, if you're going to be running a uncensored model, setting this stuff up properly the first time is important before you start running it on your computer. We'll go over picking a model. There's more out there than just Gemma or Quen. These are my favorite models that I've found so far. They're just good. For local models that are lightweight, they work great. Most people do not have the resources in their computer to be able to run Kimi K3. I mean, if you could run Kimi K3 locally on your computer, you have probably a bunch of money to be able to spend on computers, and that would be the ideal way to do it, but most people don't have that. We're also going to go over firewall. I'm going to go over some networking security aspects as well, because that is going to be important. And if you're interested in learning more about cybersecurity, my other YouTube channel, it just so happens to be called Ken Harris as well, you can find out more on this channel. Like I said, 3.5 hour video. The last time I uploaded on YouTube, it was this video. You could go over intro to OPSEC, intro to cybersecurity and privacy for home users, Windows hardening guide. We're going to be following some of the steps for this in order to get a properly configured Windows VM, if that's what you're going to run. But a lot of this will come down to networking. So that's everything we're going to be going over in part 2. It's going to be somewhat technical. If you have any questions ahead of me getting this uploaded, then you can go ahead and drop those down in the comments. Thanks for watching, and I will see you on the next one.